Hi, my name is Mel, and I'm going to, in this presentation, explore the fundamental laws of logic, tracing the historical origins of the idea, philosophical foundations, and broad applications. I'll examine classical logic principles, symbolic logic, and contemporary developments to understand the crucial role logic plays across disciplines. We will begin with an introduction to logic and its importance. Then we'll explore the classical laws of logic. Then we will review the origins of philosophical foundations, followed by symbolic logic and formal systems. We'll discuss types and extensions of logic and its applications. Logic is the study of principles of valid reasoning and argumentation. This section covers the definition and purpose of logic, its historical evolution of the idea, and the essential role in reasoning processes that underpin knowledge and decision making. Logic is a systematic study of the principles governing correct reasoning. It provides tools to distinguish valid arguments from invalid ones, helping us reason clearly and avoid errors in judgment. Logical thinking has evolved from philosophical inquiries of ancient civilizations through medieval scholasticism and modern formal systems, reflecting ongoing refinement in how we understand reasoning. Logic serves as the foundation constructing sound arguments and critical thinking, enabling structured debate, problem solving, and the pursuit of truth across principles. And truth meaning aligning with reality, okay? Classical logic is grounded in three fundamental laws that define the structure of valid reasoning. The following section introduces these laws and explains their significance. The law of identity, everything is itself. This law states that the object is identical to itself. It ensures clarity and consistency by forming that each thing has a specific, unchanging identity in terms of what its identity philosophically, okay? So I am me, you know, a fork is a fork, a spoon is a spoon, a table is a table, that sort of thing, okay? The law of non-contradiction. Nothing can be both be and not be. According to this law, contradictory statements cannot both be true simultaneously. This principle, it prevents logical paradoxes and maintains coherence in its reasoning. Okay, so I can be me, but I can't be both me and not me. Okay, I can't be me and a table or me and a fork, right? I can hold a fork, but this is its own identity. That is a fork. It's not me. It can't be both a fork and me. I am me, all right? I am myself. I am my own identity in terms of philosophically, you know, so that's what it means. You can't be both be and not be. The law of excluded middle. Everything must be either be or not be. So I cannot be both or something in between. All right. So it must be me. A fork must be a fork. A fork can't be a fork and a table or somewhere in between. Okay. There's excluded middle. This law declares that any proposition, either it's true or its negation, is true. It eliminates intermediate truth values, reinforcing binary truth evaluation. Now, and I would say this again, this only applies in terms of a philosophical identity. It does not refer to gender identity, sexual orientation, which people can be bisexual or they can be neither male nor female, non-binary. We're talking about actual physical object. So a physical object, we're not talking about someone's in terms of a sexual or gender identity. We're talking about like a fork can't both be something in between. You know, I'm not talking about a spork, which is a, you know, spoon and a fork. I'm talking that something has to be this and it can't be something, another identity that's completely separate as well, all right? So that's what I just want to be very clear in terms of that's what we're talking about. All right. The laws of logic have a rich philosophical roots. The following section explores contributions from ancient to modern philosophers who have helped shape logical theory. Aristotle laid groundwork for formal logic with his syllogistic systems, while Plato influenced early logical concepts through his dialectical methods. Medieval scholars expanded logical analysis with refinements in semantics and syntax, paving the way for early modern advances thinkers like Leibniz and Boole. Modern philosophy examines logic through new lenses, including symbolic logic, philosophical logic, and critics of traditional logic laws. Symbolic logic uses formal symbols and rules to represent logical statements precisely. This section discusses the transition from classical to symbolic logic and introduces formal proof systems. The development of symbolic logic allows for the formalization of logical reasoning beyond natural language, increasing precision and applicability. Symbolic logic employs specific symbols to denote logical connectives, quantifiers, and relations, facilitating clear formulation and manipulation of logical expressions. Axiomatic systems define sets of axioms and inference rules to derive theorems systematically, ensuring rigor and that it's as true as possibly can be. So logic has diversified into various systems tailored to different contexts. Here we outline propositional, predicate, and modal logics, among others. Propositional logic deals with propositions and their connectors, focusing on truth-functional relationships among statements. Predicate logic extends propositional logic by incorporating quantifiers and predicates, allowing reasoning about objects and their properties. Modal logic introduces modalities like necessity and possibility, while non-classical logic explores alternative truth frameworks, challenging classical assumptions. Logical principles underpin most of science and many fields. This section explores the use in mathematics, computer science, philosophy, and scientific methodology. Logic forms the foundation of mathematical proof and theory development, ensuring rigor and facilitating discovery. Computing relies on logic for algorithms, programming languages, and artificial intelligence, enabling program solving and automation. Logic guides hypothesis formulation, experimentation, and analysis, prompting clarity in schematic and philosophical inquiry. Even with logic laws, reasoning can go astray. This section identifies typical fallacies and mistakes to avoid. Contradictory statements undermine arguments. Recognizing and avoiding contradictions is crucial for sound reasoning. Incorrect use of logical principles can lead to false conclusions. Understanding correct application safeguards intellectual rigor. Common arguments contain logical errors. Identifying these helps improve communication and critical thinking in daily life. Logic continues to evolve with debates on classical logic limits and new approaches in artificial intelligence and cognitive science. Alternative logic addresses paradoxes and uncertainty by relaxing classical laws, offering nuanced frameworks for complex reasoning. Philosophers question whether classical logics apply universally or are context-dependent, fueling ongoing inquiry to the nature of logic. Logic is central to modelling human cognition and developing intelligent systems, raising questions about reasoning, learning, and understanding. Laws of logic form the backbone of rational thought across history and disciplines. Understanding their foundations, application, and challenges can equip us to reason effectively and engage with complex problems critically. Thank you for your time.